Hi everyone, this is Kalimutu. In this session, I'm gonna explain what is a case structure in virtual instrumentation using an Labview. First of all, what is a case structure? A case structure is the one which can execute one particular subdiagram, which is depending upon the input value which is given to the structure. The input value will be given to the selected terminal, which can execute a particular respective subdiagrams. The input value which determines which subdiagram going to execute. The case structure having a label in the top of it, which are having an different subdiagrams windows, which can be determined by decrement or increment the arrows on each slide. You can also click on the drop down next to the case name. From there we can also choose any one of the subdiagrams, which is initially that case structure is have an boolean stage only, which is having only true or false case, where we can given the value which gonna execute in the true and false statement, which I explain it later. If the selected terminal is given to the integer or string or enumerated data types or a ring which is having n number of cases we can given. What are the steps to create a case structure? uh, we have to place the case structure on the block diagram, wire an input value to the selected terminal, and we have to place the object to perform the what type of function in each subdiagrams. For labeling tool, enter a single value or the list and range of the values in the case selector label at the top. And this is how the case structure will look like. It will have a true and false window. uh, Initially we can give an input value to the selector terminal. Here it will look like a question mark. uh, like this, which is having a true and false window. Where we can give an input numeric to that case window, and we can get a value from here. And here the switch or any other control like boolean we can give to that selector terminal. If we press it in an front panel, it will change it. This is how when an integer will be given, like it will having a 0 default and 1 2 3 up to n. And this is how the string and enum will look like. The string will in this string we have to enter a particular name in that front panel. For enum, we having an properties in an enum, we will declare in that properties. And if we selected from a drop down box in the front panel and select any one of that, it will execute that subdiagram according to it. And we will discuss about these three examples to understand the case structure better. Switching between an addition subtraction, which we can use by boolean, and a simple calculator function, here we can use by integer or enum function. This is a sound segment display, and we will see about those examples in a detailed manner by using a Labview software. Let us do that step-by-step procedure for creating and switching between addition and subtraction program. For that, open that Labview software and create a blank VA and press Ctrl T for the equal occupying of the front panel block diagram in the screen for the better visualization. And right click on the block diagram, go to the programming structures, and create an case structure and drag and expand like this. As I mentioned earlier, it will have an true as well as false statement only. This is an condition terminal, and go to the front panel and right click on this modern and boolean. Select any one of the switch. Here I am using this switch, and I connected this one to the selected terminal. Then place the function inside the true and false statement. For that, I right click on this and go to the numeric and click on the addition, and I'm place it in a true window. This function is having two input terminals and one output terminal, and the same way I'm placing an subtract function inside the false window. And for the two inputs, I should have to go for front panel. Right click on this numeric, and I have to get an numeric control, and I have to place it here. And the next numeric for the two numeric input is required. Next I'm going and creating another numeric control. For that output, I'm going and creating one numerical indicator. Then I'm connecting that numeric control to the case structure like this. Just go and press it on that case structure, it will attach to it, and I'm connecting that numerical indicator in the same way. Okay. uh, then I'm going to connect the two input terminals to that addition function in the true window, and as well as I'm connecting this same two input memory control to the subtraction function, and I'm converting the output to the numeric indicator like this way. And after all this, just press Ctrl U for the alignment, and you can change the name in the label as input 1, and this is input 2, and this is an output like this. For the better visualization, we'll go for this one. Right click on this one and go to and click on that view as icon. Same for this one, and same for this one, and same for this one also. This will look a better effect and visualization in the block diagram. And now I am running this program continuously, and for the better understanding we can go and click this highlight execution icon for the program flow. Okay, I am going to give an input as 6 and going to input as 4. If I right now it is in the false case, so 6 minus 4, the output will be getting as 2 here. If I press it like this, it will switch to that true statement, and I'm getting an output as 6 plus 4, 10 here. Like this we can change and see what are the outputs we are getting for input for that true as well as false window. And for the second experiment which I explained earlier, the simple calculator, I'm gonna follow the same steps where I followed in a simple operation of addition and subtraction switching. Here I'm going to structures and creating a case structure here, and I will show how it will change into an numeric control while it is connected to one selector terminal. For this, going to create a numeric control here. I just gonna connect this one to one selector terminal and see the changes here. After I connecting this one, it will change to 0, which is a default, and 1. We can add n number of windows next to it, like this is a second one, and right click on this and add case after. It will add n number of cases like this, and now we can see we added two windows extra, 0 1 2 3, like this one. The same steps we are going to given two numeric controls for an input, like this, and a numeric indicator, like this. Hence I going to add an add function, subtraction, and I'm going to add like this in way, and I'm going to connect this one like this as in the previous case. The simple calculator looks like here I used multiplication, subtraction, addition and division and square function. Before I run this one, I will explain about what is the ring. For creating a ring, we have to go to that numeric and enum and go to that menu ring and place it like this, and going to the right click on this and going to the properties. It will have an edit items here. Here we are going to insert how many functions we are going to do in that case structure. After insert, it will come after this one. Hence that we will add n number, and we can add or delete, and we can move it up also like this, and we can move it down also like this, and we have to create OK. So that I created a ring here. We can give a control to the case structure, or also given a ring to also to the case structure. First I run it with a control. If I run continuously here, I'm giving an input 5 and 5 here. Initially I given a control 0, which is a multiplication operation, so 5 into 5, the result will be given as 25, and I'm giving now 1. The 1 I had an subtraction function, so I get an output like 0, and 2 I had given addition operation, so I get an output like this. So if I connect a ring also, here it will execute the same operation only. If I run this one, I can select the operation from the drop down list box. I am going to select an addition operation here. So I will get an output like 10. If I select an multiplication operation here, I will get an output of 25. And I can do the same operation by using the vertical fill scale, vertical pointer, horizontal fill scale and horizontal pointer, knob, dial. I can use it any of this, and I can connect this one to an selector terminal, and I can run. If I can select the knob like this, hence it will run according to it. Let us coming to the third and the last experiment, which is an 7 segment display. Here I used 8 LEDs A, B, C, D, E, F, G. I placed it in such a way that it has to exhibit 0, 1, 2, 3 up to 9. For this, I created a square LED from modern, boolean and square LED like this. For getting this shape, we can extend this horizontally or vertically, and you can place it like this in this way. And for getting this one, we have to go to that boolean and we have to take true and false constant respectively, and I used the true constant here and I connected to E, B, A, D, C, F and a false constant to G, so that if I execute this one, A, B, C, D, E, F will glow for the number 0 and G will not glow, so that we can get an image of 0 here. And for 1, I connected B and C only to the true constant, and the rest of that I connected to false constant, so that only B and C will glow and rest of them will not glow. I will show you clearly. Again running continuously. See, A, B, C, D, E, F is glowing. For the 0, if I press 1, it will glow only B and C and rest of them will not glow. And for 2 respectively, A, B, G, C, D is glowing and rest of the F and C is not glowing, such that up to 9 I'm getting an output like this. We can also do the same experiment uh, by running continuously, by putting all those things inside an for loop like this, and given this ith value, there is an iteration value as an input to the selector terminal, and given n value as 10 like this, so that it will run up to 9, 0, 1, 2, 3 up to 9 like this. So I will show you how it will works. Before that, include one time delay like this. I'm going to create a constant and I'm going to wait it for 1 second so that I can get a better visualization here. So I'm running here 0, 9, 2, 3, 4, 5, 6, 7, 8 and 9. I will explain how it is working. Here I mentioned 10 as a number of execution, that is loop count, and this is an iteration terminal. It will count 1, 0, 1, 2, 3 up to 9. So we are giving this as an input to that SATA terminal. So for the zeroth window will appear here and it is running, and for the one that first window is appearing, and for the two and respectively it will execute up to 10 and it will terminate. We can also do the same thing, that is adding an for loop in the previous case also. And that's it, we came to the end of the session and we got a clear idea, knowledge about the case structure and then virtual instrumentation using a Labview. Try out with more examples to understand the case structure better. Thank you.